Hello everyone, this is me Pratik. Today we will be solving a GFG problem of the day. Allocate minimum pages. So let's look into the problem. Okay, so in that particular problem we have given a array of integers where each element array of I represents the number of pages in the ith book. We also have an integer k representing the number of students that asks to allocate books to each student so that each student receive at least one book. Okay. Each student is assigned a contiguous sequences of books. No book is assigned to more than one student. Okay. The objective is to minimize the maximum number of pages assigned to any student. Okay. So in the previous GFG problem of the day as well, I already told that whenever you find a minimum of maximum or maximum of minimum, then that particular question is mostly binary search on answer. So in this also we will be applying binary search on answer. Okay, in other words, out of all the possible allocation, find the arrangement where the student who receive the most pages still has the smallest possible maximum. Okay, return -1 if a valid assignment is not possible and allotment should be in a contiguous order. Okay, so first we will be looking into the -1 case. Okay, so when we can get a -1, there is only one case when we can get -1 when the length of array is smaller than the k, because if we are having a more students and we are having a less book, then the condition cannot be satisfied. Okay, because the condition is each student should receive at least one book. Okay, let's suppose we are having only 4 books. Okay, and we are having 5 students, then we can't do that. So for that we just have to do if n is lesser than k, then return -1. This is the only case for the -1. Other than that, we just have to follow a binary search on answer template, and then we just have to write logic for the solve function. Let's write our template. Okay, low something, I will be something, low while low +1 is lesser than high, mid low plus high by 2 if solve of mid. Okay, now what we have to do is the objective is minimize the maximum number of pages. We have to minimize. Okay, so for minimize we have to high equals to mid, or if you have to maximize, then low equals to mid, and return high on here. Okay, now what could be low and what should be the high? Okay, the lowest thing could be the maximum value of the array, because let's suppose in that particular array. Okay, so we have to do, we have to get the objective of this question is to minimize the maximum number of pages assigned to any student. Okay, we have to minimize the maximum number of pages assigned to any student. Okay, so for all the student having the pages, we have to take the maximum one. Okay, and we have to try to minimize that. Okay, so let's suppose 90 is assigned to only one particular student. Okay, so at least we will be having a 90 for a particular student, so this is the minimum. Okay, so the low will be maximum of array, and high could go up to sum of array. And now here we are using low +1, so what we can do is we just do maximum of array -1. Okay, now for the solve function, for a mid m we have to check that the m is the minimum possible answer or not. For that we just do count is 1, if s plus equals to I, if s is greater than m, that means count is 1 and s will become I. Okay, so in that particular function what we are doing is we are first taking that count is representing the count of students. Okay, after that we are just adding the value of adding the pages into the variable s. If the pages is greater than m, then what we have to do is we have to assign one more student. Okay, so let's take an example for that. Okay, k equals to maybe 4. Okay, and m is currently let's suppose is 7. Okay, so for the first one what we have to do is for the first student we will be having 2. Okay, we will be having 4. After that we will be adding 5 as well. Okay, but 2 plus 4, 6 plus 5 is 11, which is greater than 7. So what we have to do is we have to assign 5 to the another student. So first student will be having only 6 and the next student will be having 7. Next student will be having 5. Okay, after that we will be adding 7 into it. That will make 12. Okay, but 12 is greater than the m, which is 7. So what we have to do is we have to take only 5 and we have to add one more student, and that another 7 will be taken by the another student. Okay, so for the next 7 we will try to add 6, which will make it 13, which is greater than the m. So we have to take another student. So this is how it will work. After that, if we are having a count like the student count is lesser than or equals to k, we have to check that. Okay, let's try to run it. Okay, it is working. Okay, it is working fine. That's it for that particular problem. If you have any doubt, you can ask me in the comment section. Thank you.